satellite orbits the Earth at a height of 400 kilometers above the surface. How much energy must be expended to the rocket such that the satellite comes out of the Earth's gravitational influence? Mass of satellite is given 200 kgs. Mass of the Earth is 6 into 10 to the power 24 kgs. Radius of Earth is 6.4 into 10 to the power 6 meters, and the value of gravitational constant is given. So let's say this is the Earth and there is a satellite which is revolving around the Earth. And this be the orbit the satellite takes to revolve the Earth. The forces acting on the satellite are only the two forces, which are the gravitational force, which acts towards the center of the Earth, and the centrifugal force, which is acting opposite to the gravitational force. And this is a circular motion, so that Fg should be equal to Fc. And the gravitational force acting on the satellite is Gmm by R naught squared, where R naught is the radius of the orbit, and this is equal to m omega squared R naught. From this we get the value of omega to be equal to Gm by R naught cube under root. So this is the value of omega with which the satellite revolves around the Earth. From this we can get the velocity as v is equal to r omega, and this is going to be equal to Gm by R naught. When we have the velocity Gm by R naught power 1 by 2, the kinetic energy possessed by the satellite is going to be half mv squared, and this is going to be equal to half m Gm by R naught, which is Gmm by 2 R naught. And also we know the potential energy when the body is at a distance R naught to the center is given to be minus Gmm by R naught. And also we have kinetic energy as Gmm by 2 R naught. So the total energy of the satellite will be the sum of potential energy and kinetic energy, which is minus Gmm by R naught plus Gmm by 2 R naught. And this is going to be equal to minus Gmm by 2 R naught. So this is the total energy which the satellite is possessing when orbiting the Earth. The criteria for the satellite to get out of the gravitational influence is the total energy of the satellite should be equal to 0. And this is the criteria for coming out of gravitational influence. So we need to add energy such that we make the total energy of the satellite 0. If U be the energy which we are adding and the initial energy is minus Gmm by 2 R naught, and this should be equal to 0 to make the satellite come out of the gravitational influence. So from this we get U is equal to Gmm by 2 R naught. So this is the amount of energy which is required to make the satellite come out of the gravitational influence. If we substitute the values, we get 6.6 into 10 to the power minus 11 into mass of the Earth is given to be 6 into 10 to the power 24. Mass of the satellite is given to be 200 kgs by 2 times R naught. R naught is the radius of the orbit. It is given it is revolving around the Earth at a distance of 400 kilometers above the surface, and the radius of Earth is 6,400 kilometers. So totally we would get the radius of orbit as 6,800 kilometers, 0.58 into 10 to the power 8. So we can write this as 5.8 into 10 to the power 7 joules.